So if you could at this time, open up your Exam Mod 5 review. Please open up question number 13 is where we left off, and we're going to go through this problem. Now for question 13, they have told us that function f has a domain of 0 to 4 and a range of 0 to 2. Start by sketching a graph, a potential graph of f. So if we drew a graph, we know that it starts at 0, stops at 4, hits a height of 2. So there you go, there's a potential graph. Now A says, suppose that our g of x is defined as f of x plus 5. Now anything on the outside of the function is going to change the range. So that plus 5 is going to take this function and pick it up and move it up 5. So your domain is still going to be 0 to 4. This time, though, your range, lift both of those ends up 5. So if we add 5 to 0, we get 5, and then add 5 to 2, we get 7. So let's put those in. Make sure, since they use brackets, you have to use brackets to include those points. Now let's look at B. B says we have a negative 3 on the outside of the function. Earlier I mentioned anything on the outside of the function is going to change the range. So we need to multiply that range by negative 3. Now the domain is still going to be 0 to 4. Haven't changed it. But if you multiply 0 by negative 3, you get 0. But if you multiply 2 by negative 3, you get negative 6. Now you might recall that if you multiply an inequality, or an equality basically, by a negative number, you got to turn the inequality. Well, that's kind of what's happening in that interval notation. You have to put it in least to greatest order. So it's going from negative 6 to 0. Let's put that one in. So those things on the outside have affected our range. Now, the next two are going to affect our domain. So C says, we have this function j of x. J of x is equal to f of negative x. So this time we're multiplying the x's by negative 1. So think about if we took our original domain and multiplied it by negative 1. We would get 0, negative 4. But that's not in the correct least to greatest order. Put it in the correct least to greatest order. That's our domain. Nothing has changed our range. It's still 0 to 2. So let's go ahead and put that in. So it'd be negative 4 to 0, 0 to 2. Let's talk about D. There's something on the inside. It is going to affect our domain. It moves it, remember, to the right 2. So we have to do the opposite of what we see. We have to add 2. So where does 0 equal x minus 2? At 2. Where does 4 equal x minus 2? At 6, or x minus 2 equal 4, I'm sorry, at 6. So you'll notice we end up doing the opposite. We end up adding 2. So x minus 2 equals 0 at 2. X minus 2 equals 4 at 6. Our range isn't going to change. Our range is still 0 to 2. So let's put those in. So that is question 13. Let's talk about question 14. It says, without using a graphing calculator, use algebraic methods to determine the roots. In that factored form, x minus 3 times x plus 2 squared equals 0, because that's how you find the roots. When x is equal to 3, and when x plus 2 equals 0 or at negative 2. Now there is a bounce there. They didn't ask that. They didn't ask about multiplicities or bounces. So we have roots at 3 and negative 2. Now it says on what intervals is the function positive and on what intervals is the function negative. So that requires us to make a very, not that rough, a very rough little sketch. Okay, we are going to hit 0 at these two spots. Our left end's going down and our right end's going up. Our lead term is x cubed. We have a bounce at negative 2. We go through negative or positive 3. So we're going to bounce, come through. Okay. Now, our function is negative between negative 2 and 3. So that's this bottom one here. So where, at what x values, where on my function, oh, and then this one. Sorry, I always want to forget that point. This one's going down. So here and here. So we're going to write them in two sections. Going from least to greatest, from left to right. From negative infinity to 2. Now 2 is a 0, so it doesn't count. That's why we have to skip it. And then again, we're below the x-axis from 2 to 3. Now, the positive intervals are where the x is where we are positive. Above the x-axis, we are above the x-axis from 3 to infinity. Did I type something wrong? Oh, this is hot. That's negative 2. Negative 2. Oop. Just a second. So good at typing. Me and technology. You understand. I am great at it and I suck at it. It's wonderful. Now let's take a look at question 15. Now question 15 is just about roots. Awesome, because for part A, the roots are, it's already in factored form. So 4x equals 0 at 0, x minus 10 equals 0 at 10. Now 6x plus 17 equals 0. You've got, I'm going to do it here on the side. Watch what happens. The 17 does become negative 17, but you do have to divide off the 6. Oh, I'm sorry. So that would be negative 17 divided by 6. And check your preview. Does it include 0, 10, and negative 17 over 6? Yes, great. B, we're going to do it again. 0, comma, 7, comma, negative 3. We didn't have to worry about any coefficients or fractions for that one. Now, C requires that you get it into factored form. For me, this is a difference of squares. So that is x plus 9 times x minus 9. We can see that we have roots at 9 and negative 9. Now, if you're not good at factoring, if you use the quadratic formula using an a value of 1, a b value of 0, and a c value of negative 81, you also get 9 and negative 9. So if you don't see that difference of squares, that pattern is something really important. Hopefully by now you've seen enough to know how that works. So that is finding roots. (16) What are the roots? It's in factored form. All of those are really nice, easy zeros. Positive 3, positive 4, and negative 9. The lead term would be the x from the first one times the x of the next one. So it'd be x times x times x. It would be x cubed. So as my, if we drew what an x cubed tells us, oh, I'm so sorry, that was so bad. It looks like that. So as my x keeps getting bigger and bigger and bigger, my y is going to increase without bound. As my x decreases without bound, so it goes down, my y is going to go down or decrease without bound as well. So that's just a fancy way, another way of asking about what your ends are doing. So that's just your end behavior. X increases, positive infinity. X decreases, negative infinity. So that's the same thinking with slightly different terminology. Let's do question 17. Recall that the leading term of a polynomial is a term containing the largest exponent. In A, our largest exponent, or the lead term, is 12x to the fifth. Now in B, it's mixed up a little bit. So in this case, it's negative 10x to the fifth. And then for C, it's hiding in plain sight. You have to include the 6, any front coefficient in front, if there's just a singular x. Our first thing has an x in it. Our next, if you multiply those x's, would be an x squared. And so we would have a total of 3 x's multiplied together. So those are the lead term questions. There is question 17. Question 18 is the formal way we were writing end behavior. Let's look at part A. The lead term in A is 9x cubed. So the left end is going down and the right end is going up. That would be those two options. The first one I checked is saying that the left is going down. The second one I checked is saying that the right is going up. B, the lead term would be negative 6 times x, or negative 6x squared. So both ends are going to point down. So the left end has to go to negative infinity. The right end has to go to negative infinity, and those are the two choices you see there. For C, our lead term is negative x cubed. So we have to flip over our cubic. So our left end, which is going to negative infinity, has to go up this time, and our right end has to go down. So those are the options that you see there. So there's question 18. So just watch that notation. Don't confuse, what you're doing. X going to negative infinity means left. X going to positive infinity means right. Y going to positive infinity means up. Y or f of x. Y or f of x going to negative infinity means down. Okay. So that's question 18. Let's look at question 19. It says, consider the polynomial. Use polynomial long division and write your polynomial in the form given. Okay, so I'm going to write this at the top. We talked about these things. I never really put it in this form often, so I do want to make sure to do it. Now I'm going to need to slide this over slightly. Okay, so I need an x squared minus 4x minus 4. That is my divisor. That is my d of x. Q of x is my quotient. It's going to be my answer. I don't have that yet. I don't have my remainder. That's my r. Okay, so let's divide it out. So as I'm writing this down, I am checking my powers. So it goes 4, 3, 2, 1, nothing. Okay, now I'm going to slide this over, and I'm going to do my division, okay? So what do we have to multiply x squared by to get negative 3x to the fourth? That would be negative 3x squared. I'm going to distribute to all three terms. I'm going to get negative 3x to the fourth plus 12x cubed plus 12x squared. But I am subtracting, so I'm going to change the signs of all the pieces. I get negative 7x cubed minus 15x squared minus 3x minus 5. What do I have to multiply negative 7x cubed by to get an x squared? And that would be negative 7x. So we get negative 7x cubed plus 28x squared plus 28x. I am subtracting. I don't know why I brought this down. I'm a little excessive at the moment. I only need 3 terms. We are changing the sign of all, so that's plus, minus, minus. X cubes go away. Negative 15 and negative 28 is negative 43x squared minus 431x. I'm so sorry if I do this wrong. Now I'll bring down the negative 5. And then I need a negative 43. So that's negative 43x squared. 4 times 43 is, so this is plus 172. And then x plus 172. And then change the signs. We get negative 203x minus 177. Okay. Now, in the q spot, that's q of x. So that goes right here. So that's negative 3x squared minus 7x minus 43. And then add on your remainder, negative 203x minus 177. Okay. Now, how could you remember that? Let's divide 5 into 24. Okay. 5 goes into 24 4 times with 4 remaining. I know that the number 24 should equal 5 times 4, my divisor, times my quotient, plus my remainder. That's what it is. So again, what did you divide by? Put it in parentheses. What did you get as an answer? Put it next in parentheses. Plus, what is your remainder? Okay, now I have to try to enter that into iMath. So we're going to get x squared minus 4x minus 4 times negative 3x squared minus 7x minus 43 plus negative 203x minus 177. Now, if I didn't make a stupid mistake along the way, nope, I didn't. We're good. Yay! Let me scooch it kind of split screen at least now. Okay, so it's just what did you divide by? Parentheses times what is your answer, your quotient in parentheses, plus in parentheses your remainder. Let's move on to question 20. So it says perform the indicated division. Now, when you do the indicated division, since it's an x plus a number, feel free to use synthetic division. I'm going to do that when it's like that. So I'm going to put negative 1/2 in the corner. I'm going to write down my coefficients, checking along the way that I'm not missing anything. This is a cube, then a squared, then an x, then a number. Now, if it just says, what is the answer to the division problem, you just need to write down the answer of the division problem. That's what's going to go in the box. It's none of that d of x times q of x plus r of x. It's just that's to perform the division. Okay, half of 10 is 5, so negative 1/2 times 10 is negative 5. Half of 46 is 23, so that would be positive 23. This would be negative 84. Half of that, maybe I shouldn't make about 3 videos in a row. That's probably bad. Okay, we'll blame it on that. So we don't have a remainder. So let me take my yucky remainder out. And we should be good. Yay. Stupid mistakes, Mrs. Hunt. Okay, let's move on to 21. It says if -2 is a root, find the other roots. So if they've given you one, jump right in and use synthetic division, because I did really good on that earlier. Use synthetic division on that problem. Okay, so we multiply, write it down, add them up, multiply, write it down, add them up, multiply, write it down. We should get 0. I did. Oh, that's good. Okay, and then put our x's back in. We get 3x squared minus 10x minus 25. And is that a factorable quantity? It is, if hopefully you recognize, if you break that up to be 3x and x, and if you break it up to be -5 and +5, you get the 3x squared, you get the -25, you get 5x and -15x, which totals -10. You could also have used the slide and divide technique we talked about earlier. So now we are able to find the roots. So 3x plus 5 equals 0. That gives us, because of that 3 on the x, a fractional answer of -5/3. And x equals 5 as a 0 for that x minus 5. So our answers would be -5/3 and 5. Now, if you are unsure how to factor that, you can use the quadratic formula. It will simplify down to the 2 answers you have seen there. 2 more to go. Question 22 says that we have a function who has a 0 at x equals 3. What factor must be included in the factor form for f based upon the information? Well, if 3 is a 0, then x minus 3 must be a factor. And then it says to use synthetic division to factor out the expression you wrote in A, and then use it to write the fully factored form. So if we do synthetic division, on the polynomial you see there, remember we should get 0 in that corner, 3, so if you make silly mistakes like I do, it would find those for you. And we get x squared plus 6x plus 5. Well, 5 multiplies, or what multiplies to give us 5? The only ones are 5 and 1. 5 plus 1 is 6, so this is going to be x plus 5 and x plus 1, which is great. So the factored form for part D, you have to include the original factor x minus 3, x plus 5, and x plus 1. So what are the zeros? Well, just set each one of those factors equal to 0. X minus 3 is 0 at +3. X plus 5 is 0 at -5. X plus 1 is 0 at -1. So that is one where we've had to use our knowledge about factoring. Okay, let's make that a little bigger so you can see it. And then finally, question 23. This is one where, see where it says the words 2 irrational roots. That means when you get to a question like this, please use the quadratic formula. Now, we're going to take out the root of -2/3 first using our synthetic division. So let me set it up, and then I'll make it bigger so you can see it. Okay, so I've set up my division box. Let's go ahead and do our division. So we're going to multiply. Well, don't get hung up on 2/3. 2 times 6 is 12. 12 divided by 3 is 4. So that's -4. 16 minus 4 is 12. Do it again. 2 times 12 is 24. 24 divided by 3 is 8. So that would be negative 8. Negative 46 minus 8 is negative 54. 2 times 54 is 108. Divided by 3 is 36. So we do get positive 36 in that spot. We do get a 0 remainder, which is great. And so now we have this 6x squared plus 12x minus 54, waiting to find the irrational roots. Now what that means is there's nothing good left. But 6, 12, and 54 are all divisible by 6. So when finding the irrational roots, you can use that x squared plus 2x minus 9. So that's what I'm going to use in our quadratic formula. And one thing we have to do is it says to separate the list in simplified radical form. Okay. So first let's apply the quadratic formula. So it's going to be negative b plus or minus the square root of b squared minus 4 times a of 1 times c of negative 9 adds on a 36 all over 2a's, which I almost did again, but 2 times 1 is indeed 2. Now, we get negative 2 plus or minus the square root of 40 over 2. Now, let's for a moment talk about the square root of 40. I'm going to do it up at the top of the page. Square root of 40, since 40 is 4 times 10, is really 2 radical 10. So, we're almost there. This is negative 2 plus or minus 2 radical 10 divided by 2. Now this, I always say all over 2a's, all over 2. So if these front numbers are divisible by 2, you can divide it one more time, and that would be fully simplified. So our final answer would be negative 1 plus or minus 1 radical 10. And then we have to separate that with a comma between them. So negative 1 plus the square root of 10, comma, negative 1 minus the square root of 10. Okay, now some suggestions. The best way to study for a math test at this level is to repeat the process. Could you do these problems again without watching the video? Try them again. Cover up the answer, write down the problem, close out iMath. Do I get the same answer I got before? Can I repeat the process? The best way to study math at this level is to repeat it. Can you repeat it? If you can't, watch the video, watch question, maybe you only need to watch question number 17. You got all the rest right, but the best way to study for math is to repeat the process. Okay, so there is a review assignment in iMath. Feel free to work on that.